Good morning, students. I am back again with our more video lecture on the topic application of double integration. Now, one of the application of double integration is to find the area of the given region. Now, let us discuss application of double integration with one small example. Now, example is find by double integration the area bounded by the parabola y square is equal to 4x and the line y is equal to 2 times x minus 4. Now solution. Now first to find the point of intersection between the parabola y square equal to 4x and the line y is equal to 2 times x minus 4. So for this, solving this y square equal to 4x and y is equal to 2 times x minus 4. Now substitute y equal to 2 times x minus 4 in the equation y square equal to 4x. Therefore 2 times x minus 4 whole square is equal to 4x. Now its simplification. So 4x square minus 20 times x plus 16 is equal to 0. Now dividing by 4, the x square minus 5 times x plus 4 is equal to 0. Now factors of 4 minus 1 and minus 4, x minus 1 times x minus 4 is equal to 0. Therefore x is equal to 1 and x is equal to 4. Now when x is equal to 1, this y is equal to 2 times 1 means 2, 2 minus 4 means minus 2. And when x is equal to 4, this y is equal to 2 times 4, 8, 8 minus 4, 4. So y is equal to 4. So therefore, points of intersection are this pair x is equal to 1 and y equal to minus 2, that is 1 minus 2, and this pair x is equal to 4 and y equal to 4, that is 4, 4. Now according to double integration, area of the given region R is equal to double integration over the region R dx dy. Now we draw the region R by using this parabola and by using this line y is equal to 2 times x minus 4. Now this is the parabola, y square is equal to 4x. Now line y is equal to 2 times x minus 4. Now by substituting y is equal to 0, we get x is equal to 4 by 2 means 2 0 means the point 2 0. Now by substituting x equal to 0, we get y equal to minus 4, that means point 0 minus 4. So therefore this line curves the x-axis at the point 2 0 and curves the y-axis at the point 0 minus 4. Suppose here be the 2 0 and suppose this point be the 0 minus 4. Now we draw one line passes through these 2 points. So this is the line passes through the 2 0 and 0 minus 4, and this is the parabola. Now this is the point of intersection, it is denoted by A, and this point is denoted by B. Now point of intersection be the 1 minus 2, its coordinate be the 1 minus 2, and this 4 4 means this is the 4 4. The region bounded between the parabola and the line, so this is the region of the integration. Now to cover the region of this integration, we draw a strip PQ parallel to x-axis. This is the strip PQ parallel to x-axis. Now this strip PQ extends from a point P. Now P on the parabola is y square equal to 4x, that is x is equal to y square by 4 to the point Q. Now this Q on the line y is equal to 2x minus, that is x is equal to y plus 4 by 2. So this is the limits of x. So here x varies from y square by 4 to y plus 4 by 2. Then this strip slides from this point A to the point B. From point capital A, that is, here this y coordinate is minus 2, that is y is equal to minus 2 to the point B. Here this y is 4, that is y is equal to 4, and therefore here y varies from minus 2 to 4. So therefore area of the given region R, area of this region R is equal to double integration over the region R dx dy. Now limits be the y is equal to minus 2 to 4 integration. Now limits of x is equal to y square by 4 to y plus 4 by 2 dx dy. Now here first integration with respect to x. So this is equal to, now integration dx, answer be the x, and its limits x is equal to y square by 4 to y plus 4 by 2 dy. Now substitute upper limits minus lower limit. The answer is y plus 4 by 2 minus y square by 4 dy. Now integration of y plus 4, answer is y plus 4 whole square by 2, but this 2 is already here, the 2 times 2, answer is 4, minus integration of this y square, the answer be the y cube by 3, and this 4 is already here, the 4 times 3 is 12, and limits y is equal to minus 2 to 4. Now substitute upper limit minus lower limit. So this is equal to, now 4 plus 4, 8, 8 square 64 by 4 minus, now 4 cube again, answer be the 64 by 12 minus lower limit, here y is equal to minus 2, so minus 2 plus 4, answer is 2, and 2 square, answer is 4, minus, now again minus 2 to the power 3, answer is minus 8, minus minus plus, now 8 by 12, 8 by 12, answer is 2 by 3. So this is equal to 64 by 4, answer is 16, minus 64 by 12, answer is 16 by 3, minus 1, and minus 2 by 3, and this is equal to 16 minus 1, answer is 15. Now minus 16 plus 2 means 16 by 3 plus 2 by 3, the answer is 18 by 3. Now 15 minus 6, answer is 9. So therefore area of this region R is equal to 9 square units. Hope all of you have understood this topic. Please subscribe the channel and let me know your comments and feedback. Thank you.